Hi everyone, welcome back to my YouTube channel. My name is Noy from Addis Ababa University and I am also a Southern New Hampshire University software engineering student. For today I am going to show you how you can solve this problem. If you are new for educational tube, make sure to subscribe our YouTube channel and get free engineering problem solutions. Now let's jump into this problem. Consider a woman standing on the earth with the sun directly overhead. As you can see, there is a woman who stands on upright position on the earth's surface and the sun directly overhead on her, and we can ask to determine the ratio of the force which the earth exerts on the woman to the force which the sun exerts on her. Neglects effect of rotation and oblateness of the earth. As you know, there is a force between two masses, and we can calculate this force by using the Newton law of Newton law of gravitation, which the force is equal to gravitational constant times m1 times m2 over the distance between the center of the two m. And by using that concept, we can calculate the force exerted by the sun on the woman's and the force exerted by the earth on the woman's. In order to calculate this, we know the mass of the earth and the mass of the sun and the distance between the center of the earth to the center of the sun. We can measure this distance by using astronomical unit. It is very important unit for astronomers in order to visualize the distance between a very huge mass substance like planets. The distance between planets are measured by using astronomical unit and other very large distances. So in order to solve this problem, first we must draw the free body diagram. As you can see here we can get a sun, and here we can get the earth, and here we can get the woman on the center of the earth, and the distance between the center of the earth to the center of the moon is the center of the sun to the center of the earth is 1 astronomical unit, which is equal to 1.496 times 10 to the power of 8 kilometers, which is a very large distance. And the mass of the sun and the mass of the earth is already known, and the mass of the sun is 3.24 times 10 to the power of 5 times the mass of the earth, which means the sun is very massive substance compared to the earth, and the mass of the sun is already given here, 3.246 times 10 to the power of 5 mass of the earth. And we can take the ratio of the two forces, and we can simply calculate our desired answer. The radius of the earth is also given, and the gravitational constant is also known. It is 6.69 times 10 to the power of -9, and the radius of the earth is 6,371 kilometers. And the force of the sun experience on the woman is equal to gravitational constant times mass of sun times mass of a woman over the radius of sun minus the distance between the center of the sun to the center of the earth minus the radius of the earth, which is the distance between the center of the earth to the woman. Which means in order to calculate the distance between this point and this point, we can subtract the distance from this to the radius of the earth, which means 1 astronomical unit minus this value. We can get the distance between the woman to the center of the sun. And the force exerted by the earth on the woman is given here, gravitational constant times mass of earth times mass of 1 over r square, and gravitational constant is given here, and mass of earth is known, and the mass of the particle is not given, but you cancel by this when you can take the ratio of these forces, and the radius of the earth is also given, and we can simply take the ratio and cancel the terms that have both in the numerator and the numerator part of these equations, and finally we will substitute the known value, and we will get 58,768. So the ratio of the force of the sun exerted on the woman and the force of the earth exerted on the woman is this value. This is all about this problem. If you have any question, you can put it on a comment section. On the next tutorial we will do the next problem. Until that, I enjoy the rest of it.